Hi, this is Presh Talwalkar. Let's play the mathematical game of spin until you lose. You have a wheel with three values of end, $1, and $2. You spin the wheel until it lands on one of the values. If it lands on $1 or $2, you bank that amount of money, in this case $1, and then you spin the wheel again. If you end up on $2 on your next spin, you get to add that amount to your bank. So now we have a total of $3 in the bank, and we keep spinning the wheel. If we land on the value of end, that means the game is over and we cash out whatever value we've banked. So in this game, we've won $3. The puzzle for you is if you play this game, how much do you expect to win on average? Some of the games you're going to end up, finishing on end right away. Other games you may continue to keep spinning and win more and more. The puzzle to you is how much money do you win on average? If you solve that problem, also give the problem of the general case a try. Imagine a wheel that has values that go up from $1 all the way up to N dollars. Each space on the wheel is equally likely to be landed on when you spin the wheel. The same rules apply. You keep spinning the wheel and banking money until you land on the value of end, in which case you cash out the banked amount. How much money do you win in the general case? Give these problems a try, and when you're ready, keep watching the video for the solution. If you try and solve this by explicitly calculating how many ways you can win $1, $2, and so on, it's going to be an infinite series that's very difficult to solve. So there's a trick. Let's imagine we have a variable x which denotes the average winnings of our gameplay. We can split up x into the three different outcomes for the first turn. This is known as the law of total expectation. So we can either consider x as landing on end on the first term, we can consider landing on $1 on the first term, or we can consider landing on $2 on the first term. Each of these are equally likely. Now if we land on end, then on the first turn, there's a 1/3 chance that we're going to end up with $0. We simply end the game. What happens if we land on $1 on our first turn? In that case, we're going to get $1 in our bank, and essentially we start the game exactly over. Because once you banked $1, it's like you started the game from scratch. You're going to expect going forward a total value of X dollars. So if you land on 1 on your first turn, then you're going to expect $1 more than X. So there's a 1/3 chance you'll end up getting X plus $1. Similarly, if you land on $2 on your first turn, it's as if the game has started over except you have an extra $2. So your expectation in this case will be that you're going to expect to make $2 more than X. So if we combine this in the expectation, we have an expression for X. We can now simplify this. I'm going to group out the 1/3 term. I'm going to have 2x, and then we have the sum of the dollar values of 0, 1, and 2. We end up solving that x is equal to $3. And this is interesting. Our average value is equal to the sum of $1 and $2, which are the values on the wheel. Is this true for the general case? Let's find out and prove that it actually is true for the general case. So if we have a wheel that goes from $1 all the way up by $1 increments to N dollars, we denote X as our average winnings, and then we're going to split up X into all the different values that we land on the first turn. These are all equally likely, and it's going to give us an expectation based on what we land on for the first turn. If we land on N dollars, remember, we're going to expect N dollars more than X. So we now have this interesting expression, and the numbers on the right go from 0, 1, all the way up to N. So these are the numbers, this is equal to the sum of the numbers from 1 to N, which is a familiar formula of N times N plus 1 over 2. We simplify this expression and we find out that the amount that you expect to win is equal to n times n plus 1 over 2, which is the sum of all the values on the wheel. So it's a kind of interesting result that this probability game, you end up with the sum of the numbers from 1 to n. Did you figure it out? Thanks for watching this video. Please subscribe to my channel. I make videos on math and game theory. You can catch me on my blog, Mind Your Decisions, which you can follow on Facebook, Google+, and Patreon. You can catch me on social media at Presh Talwalkar. And if you like this video, please check out my books. I provided links in the video description.